Good afternoon, dear students. Today we are having the first lesson of the last module in this semester, and our today practical lesson is about limits. So we will calculate limits the whole practical lesson. And now I will remind you some theoretical information. So some arithmetic properties of limits, so main rules that so we can move constant out of limit sign. Sum of so limit of the sum equals sum of limits. The same with the product. And be careful with the dividing function limits of functions. So a limit of the denominator is must not be equal to 0. When calculating limits, we often face some indeterminate forms. So some expressions that we don't know how to calculate them. So what so their values, so 0 by 0, infinity divided by infinity, 0 multiplied by infinity, infinity minus infinity, 1 in power of infinity, infinity in power of 0, and 0 in power of 0. Then we will use some special limits, such as a limit of sine of x by x equals 1. So this is the first special limit, and some consequences of the first special limit. And also we'll use the second special limit. So it looks like this, and also we will use the consequences of the second special limits. And also we have the usage of chains of infinitesimal functions in some cases. Any questions about theory now?
No.
Okay, if no questions, let we start solving tasks. So we will calculate all these limits. Maybe not all of them, but the main part. Maybe some of them that look similar, we will skip. So depending on the time. So the first limit. Let's start the calculation. So first of all, I will. Oh, no, not this. So x minus 2 and 3x in power of 2 minus 5x plus 2. So in this example, if we substitute 0, so yeah, and it, always when we calculate limits, we substitute basically this value instead of x. So if we substitute x here, what we will receive? So minus 2 in the numerator and 1 in the denominator. So basically it means that no indeterminate forms in this case. So let me write it more detailed. So it equals minus 2. So no indeterminates. So this is only for this example. Maybe any questions to me? I believe that. Yeah, questions?
Why in the denominator is x squared? Probably it's 0 square.
Yeah. Thank you for your attention.
So we just substitute x by 0.
Yeah, we substitute x by 0 and see if we have some if we have some indeterminate form. In this case, we don't have them, but only in this. Okay, so let me leave it for now. I will erase it after if we don't need it, if it's useless for now, but okay. So the next limit, so in at the point x minus 2. So if we substitute x, or if we substitute minus 1, what do we receive? So in the numerator, 0. So in the denominator, 1 minus 3 is minus 1, 1 minus 3 is minus 2, and plus 2, 0. So we have such indeterminate form, 0 by 0. Any ideas how to eliminate it? What can we do?
We need to factorize this equation.
Not equation, but expression. Yeah, so
Expression.
I will correct you a little bit. Yeah, and always be attentive. So when you solve tasks so when you calculate limits, don't forget to write always a limit of the function. So until you substitute numbers. So it is the common mistake which beginners do. Oh. So factorizing numerator, what do we have? And the denominator, so let's find some roots of the square equation. So if we imagine that this is the equation, so minus 1 and minus 2. Yeah. So x plus 1 by x plus 2. Let me double check. So x in power of 2. So 1 plus 2. So 3x and 2. And what can we do in this case? We can just reduce. So we can eliminate, so cancel this multipliers, and what we have, so such limit, but still a limit. And now we are substituting numbers. So now the sign of limit we don't use. So it equals minus 2. Any questions about this task?
No.
Okay, no questions, so moving next. So x in power of 3 plus 3x in power of 2 plus 2x and divide by divide by x in power of 2 minus x minus 6. So what do we have? So minus 8 plus 12 is 4, and 4 minus 4, 0. And in the denominator, so 4, yeah, 4 plus 2 minus 6, so 0. Was it unexpected? Basically not. It wasn't unexpected because examples without indeterminate forms are not interesting. So doing the same. So we need to factorize all expressions that we have. So first of all, moving x out of brackets in the numerator, and what do we get here? So this. So what we have, and continuing factorizing. So what do we have? So four, yeah, basically roots of square equations. What we have here? No, basically like here. So just let me copy and paste them to save our time. Why not? We can do it. Okay, and here x, okay, so minus 2 and 3. So x minus 3 by x plus 2. Let me double check. So x in power of 2. So so 3 minus 3 plus 2 minus 1. So minus x and minus 6. And now let's cancel x plus 2. So what we can eliminate? And now substitute in minus 2. So no indeterminate forms for now. And the final answer, minus 2 by 5. Any questions about this task?
No.
Okay, no questions. So moving next to part D. By the way, is it so math type is convenient for you? This application.
Yes.
So for using formulas, okay, good. So for now we will work in this software. So the same indeterminate form, 0 by 0, and as well we need to factorize this expression. Any ideas? What can we do in this case? So currently it doesn't look so easy. So what, maybe you remember something from the school, how to expand, how to factorize uh, polynomials in power of 3. Daniil, yeah, go on.
First my opinion was move out of brackets x, and it will be x multiplied by x squared plus 1, and out of brackets minus 2. And probably it helped.
Well, yeah, we will divide both parts by x minus 1. Yeah, to move out of the brackets, because 1 is the definitely root of this equation. So if this part will, so if the denominator or numerator will be 0, so yeah, it would be the root. So we need to move it out. And how to do it? So again, we will use paint, but we don't, so we won't use it so often for now. So what do we have to do? So we need to divide, so divide in the numerator. So x in power 3 plus, I will also write coefficient for x in power of 2 plus x minus 2, and dividing it by x minus 1. Okay, so firstly divide. So do you remember such a way of dividing? Yeah.
Yes.
Okay, so currently we dividing this senior member. So x x in power of 3 divided by x, so we have x in power of 2. And then multiply it by x in power of 2. So x in power of 3 minus x in power of 2. And we receive x in power of 2 plus x. So now dividing by x as well. So x plus 1 so x minus, stop. Yeah, correctly. Everything is correct. So x, stop. No. Yeah, for x here. So not correct. Mistake here. And here we have 2x. 2x minus 2. And if we divide it, so what we have, so plus 2. So expanded for now. No, let me leave it without changes. So, and I will write down it here. So x minus 2 multiply by x in power of 2 plus x plus 2. And by the way, we cannot expand it. So this expression, because it has only complex roots, so the discriminant is negative. So 1 minus 8, so you see. And now we're expanding the denominator in the same way. So just for your practice, because you definitely will have such examples in individual tasks. So 0 here. So x in power of 2. So minus x plus 1. Yeah, and by the way, so minus 1 here. So basically what we have, x minus 1 and x in power of 2 minus 1. Canceling this multipliers. And now if we substitute 1, so in the numerator we have 4, in the denominator we have 0. So this is not the indeterminate form, and the answer is infinity. Any questions? Yeah, let me also check here. Yeah, so infinity, so the same. Any questions about this task?
No.
Okay, if no questions, let's continue. So the next exercise E. So calculating the next limit. So as well, we have the indeterminate form 0 by 0. So the question, how to solve this exercise, how to simplify, so how to eliminate such indeterminate form? How can we transform this function, these expressions? So we cannot expand, so we cannot factorize. Yeah, Daniil?
I think we can make formula under square root like 1 plus x square plus 2x and minus 2x. Something like that.
Okay, so what do you basically suggest? So plus 2x minus 2x, and what does it give for us? So
Perfect square. Oh.
So we will have a perfect square only for this. So and so what will we do with? By the way, so one no, basically, so the indeterminate form will no go away. So if we substitute 0 in this expression, we will get 0 as well.
But then we can minus square root of 2 multiplied by x and use formula a square minus b square equals 2 brackets where a plus minus b.
Well, we will use so the formula a square minus b square, and how we will use it? So we will multiply the numerator and the denominator to the by the conjugate expression. So how will it look like? So I'm multiplying by this expression and also divide. So equality is not broken, so everything is correct. So and now we will use formulas, yeah, of shortened multiplication, or how it called correctly, forgot a little bit, but nevertheless. So what are we having here? So this expression in power of 2 is the following. So 1 plus x in power of 2 and minus 1. And what do we have here in the denominator? The next expression. And now let's continue transforming and simplifying the equation, not equation, the limit. So what we have here, x in power of 2, and here x. We can reduce x. So x goes on, goes away, and power of 2 goes away. And also I can get rid of brackets. We don't need them. And now if we substitute 0, so no indeterminate form. So 0 divided by 2. So it equals 0. So any questions about this task? So did you understand the idea how to eliminate such indeterminate forms?
Yes.
Okay. To improve knowledge and skills, in this case, let's solve more exercises related to limits. So, section F. So the following exercise are on hotkey. So the same. If we substitute 0, we will get indeterminate form 0 by 0. So 1 minus 1 and 4 minus 4, and that's not what we need. So doing again the same that we wrote we did in the previous exercise, but here we need also multiply the expression by the conjugate expression of the both so both for numerator and for the denominator. And let's do it. So firstly, numerator. So what we firstly transform the numerator. So just not to confuse you. And what will we have here? X plus 1, x in power of 2 plus 1 minus 1. What's going on? Okay, and continuing transforming the denominator for now. So now multiplying to this by the conjugate expression of this expression. So plus 4, so leaving without changes it for now. And doing the same here. And now expanding the brackets in the denominator. So what we will have in brackets, so x plus in x in power of 2 plus 16 minus 16, and removing it. So writing it, so typing it in details for now. So here we have only x in power of 2, and then we will also x in power of 2, so it will be cancelled as well, so we will reduce it. So x in power of 2 goes away. And now we can easily substitute 0 and no indeterminate forms for now. So what we have here, so fraction, so x, so 0, okay, 0 in power of 2 plus 16 plus 4. And the same, 0 in power of 2 plus 1 plus 1. So basically what we have 8 by 2, so it equals 4. Any questions about this task?
No questions.
Okay, no questions, so let's continue. So now G. Then, so what we have, x to 8. So x minus 8 divided by, so a root of, so cube root of x minus 2. So again, indeterminate form, so 0 divided by 0, how to solve it? So what can we use here? Which formulas, so which methods to eliminate such indeterminate form? Any ideas? Okay. So what about difference of cubes? Or do you remember? Okay, I will remind you. So this is also a useful formula. So to eliminate such indeterminate form, we will factorize the numerator using formula of cubes differences. So we will cancel the denominator, and basically no fraction will be in this expression. So do you understand the idea?
In general, yes, but we need to multiply by second bracket.
So we need to factorize this expression. So this expression is basically the cube of, so the difference of cubes of these numbers. So this is x and this is x, so cube root of x. And 2 in power of 3 is 8. So we just factorize. So do you understand the idea now?
Yes, we already had formula.
Yeah, so just reminded you. So here x, yeah. So x in power of 2 by 3 plus 2 cube root of x plus 4. So reducing the denominator. And now we have no indeterminate forms. So what we basically receive here. So cube root of 64 plus okay, 2 by 2. So none. And plus 4. So cube root of 64 is 4. So the answer is 12. Any questions about this task? So it even looks simpler than F. So less calculations and less transformations. So any questions or no questions?
No questions.
Okay, now going and so moving to the next part. So next exercise. So H. Here's my limit. So now we are calculating limits on infinity. If we substitute minus infinity into this expression, we will receive the following indeterminate form, so infinity by infinity. And we generally cannot be sure what does it mean, because it's indeterminate. How to solve such exercises, so how to eliminate such indeterminate form? What do you remember about it? So any ideas? Any idea?
We also need factorize.
Yes, but how to factorize in for such indeterminate form? Yes, go on.
I am not sure, but denominator must be 0.
Why? Because so we substitute infinity here, so denominator equals infinity for now.
I mean after factorizing.
Oh, I understand what you mean, but basically how to factorize in this case, we need to move we need to move the highest power out of brackets. So, and we will do it both for the numerator and for the denominator. So, moving x in power of 2 out of brackets here. And what will we receive? So 1 1 by x in power of 2 plus 1 plus 1 by x, and minus 3. And the same for the denominator. So 1 by x in power of 3 plus 1 by x plus 3. And now I will reduce x as much as possible. So here it goes away. Here I just reduce the power. So currently, if we substitute infinity here in the denominator, so in the numerator, we will receive 0, and in the denominator, so infinity by sorry, in the numerator, so if we substitute infinity instead of x, we will receive minus 3. So 0 plus 0 minus 3. And in the denominator, we will receive, so infinity by, so 0 plus 0 plus 3. So infinity by 3. So multiplying infinity by the constant gives us infinity as the result. So this is a determinant form, absolutely. And so it basically equals infinity. And dividing constant by infinity will give 0 as the result. So any questions about this exercise?
No.
Okay, if no
Also,
question, so you have a
I
question.
remembered that lecture said that we need винести найбільшу ступінь з обох.
Well, we can do, yeah, I understand the idea. Yeah, we can move out of brackets the highest power, and basically it will be more informative for us, more useful. Yeah, better to do like this. So if I move the highest power of both the numerator and the denominator, what I will get? So this and 3 by x. So what will change?
Sorry, put x замість трійки, там де
Yeah. So misclick or mistype. So correct to say correctly. Yeah. So now what we have? So 0 plus 0 minus 0 in the numerator, and in the denominator 0 plus 0 plus 3. So we divide 0 by 3, and of course 0 is the result. By the way, so here, yeah, in these materials, yeah, I moved the highest power out of brackets. Yeah, so better do solve in this way to avoid mistakes. So now any questions?
Oh, thank you.
Okay, if no questions for now, let we solve one more exercise and then have a break. So again, moving out of brackets, so moving at the highest, member with the highest power. So x, x in power, so 4 is the highest power. So it was no need basically to type it more than we had to. So 5 by x in power 3. And doing the same for the denominator. So 1 by x in power of 2 minus 3 by x in power of 3 plus 1 by x in power of 4, and removing it. And now we will reduce, so we'll remove x in power of 4. And now no indeterminate form. So x, so 1 minus 0 divided by 0 minus 0 plus 0. So the answer is infinity. Any questions for now about this exercise or about previous?
No.
Okay, if no questions, we'll have a break for 5 minutes and then continue the lesson. Let's continue. So I will skip exercise J because it is almost the same, but you can do it in your own. It will be useful for you, some more practice. And now let's move to K. It's not moving. Now better. Okay. So the limit is the following. Okay, so any ideas how to solve this exercise? So is it so the same idea or not? Well, basically idea is the same. Oh. So here I will move the greatest power out of brackets, and the greatest power is 1. And here, just I'm moving this square root into the denominator. Okay, and now for this part, so moving x out of brackets as well. So what do I have? And -1. And now reduce an x. So currently, if I substitute infinity, I will have no indeterminate forms. So what I will have? 1 plus 0 plus 0. And here as well, 0 minus 1. So the result is -1. Any questions about this task?
No.
Okay, no questions. So now moving to the next exercise, exercise L. So the following limit. X approaches 1 and the limit is the following: 1 by 1 minus x minus 3 divided by 1 minus x in power of 3. So, which indeterminate form do we have here? So, what can you say about it?
Probably we can here use formula with cubes.
We can use formula with cubes, but so which kind of indeterminate form? Okay, so the indeterminate form is the following: infinity minus infinity. Yes, and we will use the formula of cube difference to to transform this expression to the fraction with the common denominator. So what we will do, x in power of 2 minus oh no, plus x and plus 1. And now let's also so subtracting 3, we will get the following. So this expression. And now we have the indeterminate form. Stop. So no indeterminate forms, really? So, minus 2. Yeah, my bad. Nobody told me that something is incorrect, but yeah, maybe you just... So, не встигли. Okay, so the indeterminate form now is the following: 0 by 0. How to deal with it, we already know. So let's factorize these expressions. So first of all, let we factorize the denominator because of usage cube difference form. And for the numerator, so minus 2, the first root, and 1. Yeah. So what are we having? So x minus 1 by x plus 2. Now checking it. So x in power of 2, so minus 1 x plus 2x, so plus 2x and minus 2, yeah, so correct. And now we can reduce these brackets, but be attentive to signs, because as you see, they are a little bit, so here we have the different sign. So here x minus 1, and here in the numerator, and in the denominator 1 minus x. So now change the sign, so minus is here, and I will just reduce these expressions. And now we have no indeterminate forms. So basically the answer is -1. Any questions about this exercise?
No.
Okay, no questions. So now continuing. So moving to the next exercise, exercise M, and we have the limit when x approaches infinity. So the same, we have the indeterminate form infinity minus infinity. And first of all, we need to find the common denominator. So let's do it. As we can see, we can use the formula of square differences. So 4x in power 4 minus 1, and the same here. So let's expand the brackets. So 4x in power of, oh, no, not 4. 2x in power 4 plus x in power 3, then minus 2x in power 4 plus x in power of 2. So let we check once more. So here is, so this part is correct. Then minus 2x in power of 4 plus x in power of 2. So correct. And now we have the following indeterminate form. Yeah, by the way, first of all, let's reduce. So let's cancel this powers. Yeah, and we have the indeterminate form infinity divided by infinity. And we did the same that we were doing before. Yeah, so the answer seems to be obvious, but let me write it in details as well, because that's a good practice. Not to be lazy, to write everything in details. And with canceling x in power of 4, we are receiving the next. So 0 plus 0 divided by 4 minus 0. And the answer is 0. Any questions? No questions. Okay. So moving next. to the exercise n, and here we have other limit. So x approaches 0, sine of 3x divided by x. We have the next indeterminate form, 0 divided by 0. So how to solve it? Any ideas? What can we use here? So we will use the first special limit. So we will transform this limit to the first special limit and then use it. So as we can see, it is similar. And how can we do it? So we need to multiply the so the numerator and the denominator by 3. Oh. So what will we have? And then so we can even move 3 out of the limit sign, so as a constant. Basically what we see, it is the first special limit. Also, we can even make a substitution just to make everything ideally correct, so the correct procedure. So we can make the following substitution. So t equals 3x. And so x approaches 0, and t approaches 0 as well. So if we make such substitution, we will receive the next. So t approaches 0 and sine t divided by t. And what we see, this is the first special limit. So it equals 3. Any questions about this task? Okay, as I see, no questions. So moving next to this exercise O. So basically doing almost so the same things. Tangents over to x by sine over 5x. And here we also use consequences of the first special limit. Yeah, again, the indeterminate form is the following. So I will multiply the numerator and denominator by 2x for now. And I will remove this indeterminate form. So 2 tangents x by x. So yeah, so just ideal variant how to write it. So as the product of limits. So how will it look? And here we have the next. So we just wrote it as the sum of limit. So it will be equal to 1. So just reducing it. And what remains? So 2, a limit of x by sine of 5x. And now let's multiply the numerator and the denominator by 5. Yeah, we can see that the first special limit looks like that, that the sign is in the numerator and x in the denominator, but if we turn over the fraction, nothing changes. So I guess that you agree. So then as well, so writing everything is in details. So moving all constants out of limit, and it equals 1. So this limit. And don't also forget to multiply by the constant. So 2 over 5. Any questions about this exercise?
But why 2 over 5?
So important. Don't lose coefficients. So first of all, we eliminated tangents. So I multiplied by 2 and divided by 2. And and I have transformed limit to the product of limits, and here we have tangents x by tangents to x by 2x, and here we have 2. So 2 remained here, and it just equals 1. Then moved 2 out of limit sign, and then multiplied and divided by 5 to do the analogical operation, so to perform analogical operation to the sign. And as well moved 5 out of brackets, and this is this is not the first special limit, but the consequence of the first special limit, and it equals 1. And the result, so 2 over 5 multiplied by 1. So did I answer your question?
Yes, I understand.
Yeah, be attentive with such multiplication, so with such arithmetical transforms, because you always can face such problem. Yeah, so try not to make mistakes. More questions about this exercise? Okay, moving to the next section, next exercise. So now we have the next limit, 7 of 7x divided by sine of 7x plus sine of x. How to solve? Any ideas? What can we use here? Daniel?
Probably we can use formula of addition of signs.
We can, but we don't have to do it. Basically, currently we can use another approach to simplify. So adding trigonometric functions takes some time, but we can do it simpler. So other approach for limits. We will use the chain of the infinitesimal equivalent chain of equivalent infinitesimal functions. So, ланцюжок нескінченно малих функцій. So, as x approaches 0, so what will be equivalent? So sine of x is equivalent, so sine of x in this case is equivalent to x, and sine over 7x is equivalent to 7x. So we will replace signs just with the linear parts, and it will simplify our calculations. So no need to add trigonometric functions. And basically we just have 7 by 8. So this is the final answer. Any questions about this task?
We can do this operation only when our limit approaches to 0. Yes.
For infinitesimal functions, so yeah, when to 0. Correct. Also, there are нескінченно великі, I forgot the uh, term in English, but yeah, so we have also the opposite case, so functions that equivalences that we can use for infinite limits. Yeah, but here are such equivalences. So sine of x is equivalent to x. And tangents of x is equivalent to x, arc sine, arc tangents, and we will use other formulas, so other equivalences as well. So moving to the Q part, or you had questions? Okay, if no questions, let's continue. So the same, we have so a limit with the trigonometric functions. And in this part will be, so in this case also will be a good idea to use equivalent infinitesimal functions. But first of all, let's transform these functions. So let's transform the numerator just to understand what else we are going to do. So 1 minus cosine of 4x will be transformed to 2 sine of 2x. So such trigonometric formula. Yeah, and also I will move 2 out of brackets, so out of limit sign. And now using using equivalences. So when x approaches 0, so we have so we will use the following equivalences. So 2x sine of 2x equivalent to 2x, and sine of x is equivalent to x. And now we will replace these equivalences. So trigonometric functions just with the x, so with linear multipliers. So in the numerator we have 4x in power of 2, and in the denominator x in power of 2. And the answer is 8. Any questions about this exercise? Is everything is fully understandable?
Yes.
Yeah, so I recommend you to review some trigonometric formulas because they will be useful in your tasks. Okay, now moving to other kinds of limits. So what do we have here? 2x by 2x minus 3, and in power of 2 minus 5x. So we have the following indeterminate form, 1 in power of infinity. For this indeterminate forms, we use the second special limit and its consequences. So, but in this case, we cannot use such limit in the explicit way. So we need to transform this expression, of course. So it must be look like this: 1 plus 1 minus, so 1 plus 1 by x. And how to do it? We just add 1 and multiply 1. So if we, no, add 1 and subtract 1. So if I subtract 1, I will receive, so 2x minus 2x plus 3. So 3 here. And now we can use no, not now, but so transform into the second special limit. So doing the following, so performing the following actions. So this will be the next. So I'm multiply the exponent by 2x minus 3, and also I divide it by 2x minus 3. So nothing changed, just such a kind of transformation. And here I can use the second special limit. So this limit will be equal to e. So Euler number. So it looks like this. But now we also need to deal with this indeterminate form. So it equals, yeah, but we also can move e out of the limit. So it will look like that. So e in power of such a limit. And now let's calculate this limit separately. So basically it's quite easy. We have the following indeterminate form, infinity by infinity, and we see how can we transform it. So we will multiply everything. So we will divide by x, 2 by x minus 5, and 2 minus 3 by x. And we have, so minus 5, so 0 minus 5, and 2 minus 0. So the answer is minus 5 by 2. But be attentive that this is not the final answer. So we need to find this limit. So this limit. So the final answer will be the next. So I will write it here also. So the final answer, e in power of, so in power 5 by minus 2. Any questions about this task?
А там, де поділося мінус 1 першій строчці?
This,
Тут,
okay.
да.
So I subtracted 1 from this fraction. So basically it equals, so 2x minus 2x minus 3. So just some arithmetic transforms. So have I answered your question?
Yes.
More questions about this task? Okay, if no questions, let's solve the last exercise for now. Just so we have some time, and I guess we will do it in time. So one more usage of such limits. So the second special limit and its consequences. So so as well we have yeah. So which indeterminate form do we have? So 0 in power of infinity. So such in oh no, uh, 0. Yeah. So 1 in power of infinity. I forgot about this e. So as well, we need to so we will solve this exercise with using the second special limit and its consequences. So I will expand this expression in brackets and modify to use correct formulas. We don't need it. So let's regroup components. Yeah, and by the way, I will make a substitution here for our convenience. So t equals x minus 1. So x x approaches 1 and t approaches 0. And it will be easier for us. It will simplify the calculations. So t equals, so t approaches 0, t here, e in power of t, and 6 by t. So what we have here. And now we will use also some equality, such kind of equivalent chains of equivalent infinitesimal functions. Something, but by the way, I'm confused a little bit. That what I had to do. Yeah, so I made a mistake. Yeah, so incorrect transform. So what basically I had to do? So the next transform. So yeah, first of all, just make the substitution would be a good idea, and then performing other actions. Just forgot a little bit. So now what I do, I modify this so analogically to the previous task. So I add 1 and subtract 1. And what I basically have, so the following expression, 1 plus 2 e in power of t minus 1. And in such cases, so we use also infinitesimal equivalent functions. So when t approaches 0, e in power of t minus 1 is equivalent to t. And I have the following limit. So the following form. So 1 plus 2t in power 6 by t. And then I transform it to use the second special limit. And then doing analogical manipulations, and I have the answer is e in power of 12. Any questions about this task?
No questions.
Okay, no questions. Maybe questions about this lesson, previous lessons.
Can I ask the question about my individual home task?
Yes, you can.
Can I send you?
So you mean in messages, yeah?
Yes, because in Word складно пояснити. Там в мене виходить, що фокус це для
Окей, ну поясніть, давайте не на пальцях, а поясніть вже в повідомленні в Гуглі, яка проблема.
Добре.
Там зі скрінами, щоб було краще зрозуміло.
Добре.
So, by the way, so dear students, always feel free to ask me questions. If something is not understandable, you can contact me in Google chat, so on Dell. So basically, yeah, so Gmail and Dell. So the ways that are allowed currently. So more questions, or that's all for now. Okay.
No.
If no questions, so have a nice day. Stay safe. Goodbye. Thank you for your attention.
Thank you for the lesson. Goodbye.
Goodbye.